Wow. Yeah, go ahead.
To prepare us to go to the moon and Mars. Lastly, in the last, I would say about a year, I've gone ahead and left management. I'm no longer in the management chain here at NASA. I am doing my own independent research with a group of engineers and scientists. We worked on a system called Kaboom. The Kaboom system was an array radar designed to look at meteors. And we did the first two technology developments on that, where we're able to array three antennas together. And then recently, I'm working on a program called Shark, and that's science and heliophysics antenna array for radar and communications. And that project, we're building a solar radio burst detector where we're going to be looking at the sun, looking at specifically looking for solar radio bursts, those energetic flares that will can affect life here on Earth. So that's a summary of my education background and my career at NASA.
So you mentioned optics, electrical engineering. What inspired you to take this career path and focus it on those disciplines?
Well, back when I was getting my undergraduate at University of Illinois Chicago, I always found that the electromagnetics was challenging, and there was a good professor there that really, everyone said, "Hey, this guy's tough. Oh, this can be a tough class." And so that was that lit a bit of a challenge in me. So I took that class and I really enjoyed it. And then as part of my internship, they put me in that special instrumentation branch where we were doing RF systems and shuttle navigation aids. And that was basically the thing that set me down that path of RF. And then when I and RF and optics, it's all one continuum. As you go higher and higher in frequency, your RF signals look more and more like optical signals. But when I was interested in getting my PhD, and Dr. Ron Phillips from the University of Central Florida, he was recruiting students to work on optics and optical communication. So as part of my PhD work, we did high-speed optical communication links, primarily ground to ground, and as the latest technology in optics. How's that for an answer? Thumbs up.
Good.
Wonderful.
It's really interesting. So one thing I wanted to ask was, I know you mentioned how you were a senior project manager, and like, do you still happen to work on any of the hardware on and like the stuff you've talked about so far, or are you just like managing the people that work on that stuff?
Well, as I explained, I've gone ahead and I've always had one foot in the research area, and so uh, I've left managing people. And when I was managing the group, it was a group of 3 branches, so there was about 50 engineers as part of that. But now I'm working on my own independent research. I'm managing myself and supporting the project manager that's running the project for this.
So we're an FTC, so we have our own little team of workers and the same idea and premise. You're leading your own research team. What are some of the things that you do to organize your team and keep them motivated?
Well, it's there are technical goals. There's the budget, and there's the schedule, and those are your 3 things that you're balancing as a project manager. And so what you do is you work and set up the budget, and then hopefully you've got some support where you're tracking that budget periodically. If you don't, depending on the size of the project, you may have somebody that just manages the schedule and the budget, and you provide inputs and have periodic meetings. During those meetings, you review where you stand in terms of your risks, your budget, your schedule. See where you stand. If you see things starting to slip, you address those. In terms of motivating them to do the job, I mean, the job here at NASA is a lot of fun, quite honestly. And so, they do not need direct motivation from me. When I managed our group of folks, most of the people were PhD researchers. They had their own internal motivation, and the work we're doing is, of course, we publish it. We publish all the work we do. We're proud of the work we do, and people are receptive and encouraging when they see stuff from NASA. So the work itself is rewarding. Most people don't require significant motivation. But time to just to go to answer your question a little more directly, Lily. If you have struggles with 1 or 2 or a few individuals on the team, what you have to do is set aside and find out what are the things that they really enjoy doing, and then, if necessary, change their role as best you can to align their capabilities with and what things they enjoy with what tasks need to get done. And that's probably the best regulated, where there's I can't export technology or items. So you do have to be careful when working with the folks, and make sure that you're direct and there's no misunderstanding, and otherwise everything goes well.
Tom, got anything fun to ask?
Can you hear me? Okay. So, I myself, like, what type of
Kennedy Space Center is a small city, and just like any city, all sorts of services are needed. We have a lot of people with technical degrees that are project managers, and past engineering, past the aerospace and mechanical, electrical. We've got a lot of folks that have technical backgrounds, whether that's mathematics or physics. Actually, let me go step back. Our mathematics and physicists generally are funneled towards the research, and so folks that have those pure sciences or pure mathematics tend to work primarily with the research team. And then there's the technical people who are project managers. Also, a lot of people with business backgrounds also fall into that product manager category. But as any small city, there is a whole organization that manages money. So folks that have degrees in finance and business end up usually falling in that group and managing that part. Of course, there's technicians for those who don't end up going to college. This place doesn't function without scores and scores of technicians, building and constructing and manufacturing and making things. We have lawyers, doctors. We have a whole group for basic city services that you would have in any city, from purchasing, warehouse logistics, sanitation, janitorial. It's everything's here. But remember that when it comes to NASA, it's primarily a smaller group. So there's 2,000 or 50. I think right now it's 1,800 to 1,500 civil servants. Many of them are in engineers, but if you don't actually work for NASA, you can work for our local contractors, and those contractors, while they go from company to company, they are usually here for most of their careers as well. Sure. So we have 2 health clinics here at KSC. They provide support for occupational health. So most of the people that are workers are required to have exams for occupational health and screening, ear testing, eyes. If you're working with lasers, for example, you have to go for a periodic laser check. If you're going on aircraft, you have to have local physicals to support that. And of course, those doctors are here supporting our local health program. I mean, we just went through, and we're still in the middle of COVID, and it's the KSC doctors that are making the calls on what is safe to work, what is safe to gather, how to manage the folks during this time in COVID. In addition, that same physician crew also supports our astronauts. They're the flight surgeons. So whenever the astronauts are here and prepared to launch, you count on your flight surgeons to make sure everything's make sure the astronauts are supported.
Okay, I see. That's interesting. So we have a fun question now for you. If you could have a superpower, what would it be? Any superpower?
I think I'd like to read people's minds. I think I would be better prepared to work with others if I knew what they were thinking. And so I think I'd really enjoy that.
No laser hands.
Well, let me fill in a few more things. That way, you don't have to ask me the questions. Let's see. If you're for high school folks and folks going to college, if you really want to come work for NASA, there are certain paths I would recommend. Of course, there is a small high school program. They do bring in high school people once in a while, but primarily the way to work at the Space Center is to work through internships. So I believe, and I'm going to look at my other screen here to make sure I have the right address. It is intern.nasa.gov. So if you want to come work for this Kennedy Space Center or for NASA or for any space center, quite honestly, whether that's here, Washington, D.C., there are 10 NASA centers all over the country. The best way to do that is to start with an internship. So, work with whatever college you end up going into after you graduate high school. Work with their career counselors from day one. Don't wait till your senior year. Go see the career counselors during your freshman year, right as you get in there. They have the direct paths for internships. And usually by December of the year prior is where you want to be applying for your summer internships. So, for you seniors that are at high school, you're going to start your first year of college right after the end of football season, right at winter break. You should be applying for internships in the future. Now, we don't get a lot of freshman interns. Usually you wait one full year, but that's not a hard, fast rule. A lot of it depends on your background, your educational background, courses you've already taken. So if you have an interest in working for NASA, that's the path I would recommend.
What advice would you give to those applicants? Just in general.
Be persistent. Keep on applying. Keep on checking. There's two paths for NASA. One is something called Pathways, which is an internship path where you actually work for the federal government. A secondary path where you're a contractor. You're still a NASA intern, but you're not working for the federal government. You're getting paid a set wage for the summer. So that's two ways of becoming an intern. Not to mention all of the other contractors out here, they all have interns as well. Lockheed Martin, Boeing, SpaceX, all those other folks end up working for or with NASA as well. So as long as I'm talking, I'll give you another. So my electrical engineering background, like I said, I talk mostly about electromagnetics and RF systems, but I can program in C and Python in other languages. I program on Arduinos, Raspberry Pis. BeagleBone AI is the little board we're using right now. I'm doing some software development using something called an RF SoC. So that's a RF radio frequency system on a chip as part of a field programmable gate array development board. So that's basically a Arduino multiplied by 10 or 100. Using the Xilinx field programmable gate array and all that good stuff. So
there is an intermixing between all the different disciplines.
Well, really, I don't think any discipline, whether you're mechanical, electrical, they all depend on programming. Now, you might not have the same expertise and skill that somebody who's actually going for computer programming or computer science, they'd have a much stronger background. And in terms of building computer systems and capability, they're the experts you want to turn to. But every engineer requires a background in programming and operating and controlling. That's what you do from the start. I remember one of my first systems that I built was we took a tracking radar, and we added our own instrumentation as part of it. I built an interface to a tape deck. We actually used tapes back then, and collected data from the radar system and sent it all. Did some digital signal processing, compiling, displaying. So that's all part of it.
So some people have put their questions in the chat. So if you don't mind.
Okay.
So what is your favorite part about working right now?
Well, the work is always a lot of fun. I mean, you get to see the what you're doing during those times, like during launch. I love watching a launch. I'm not as much involved in launch anymore, whereas the rest of my family is. But I know that my contributions go towards that. And I know that the work we do on NASA is internationally recognized. As I said in my interview that I typed up, there's not many jobs where people will wear the T-shirts of the organization you work for. I mean, I can walk around like you're today. Go ahead and scan your camera down there. On your shirt.
Stand up.
I mean, how many groups will people wear NASA shirts? I mean, how many jobs where somebody's going to wear the shirt where you work? There's not many like that, and so how could I not like it?
And you get to casually refer to yourself as a rocket scientist.
That's right.
Not as a joke.
That's the best part. So another question we have is, how did the end of the shuttle program affect your job and your position?
Well, the work I was doing ended, so I had to find something else to do. Part of it, there was a lot of time spent in shuttle retirement. What we wanted to do is transition so that the Space Center was prepared for what was coming next, and what was coming next wasn't exactly well defined. They started with Constellation, that ended up getting canceled and changed. Actually, even before that, they had some ideas of other shuttle type vehicles, and then there was a big push for commercialization at the Space Center, where a lot of the capability was treated differently. Instead of the government making all the decisions and running everything, we let commercial providers actually be a participant, where we weren't just paying them, they invested their own funds, and they developed their own areas. For example, there's Pad A, where we launched Apollo and shuttle from. LC-39 Pad A was leased to SpaceX, so they leased that whole pad. Boeing leased a lot of the operational processing facilities. Blue Origin built a whole new rocket factory, as did OneWeb, right here on the Space Center. So as part of that transition, we didn't know that at the time, right at the time the shuttle ended, but we had to position Kennedy Space Center to be open for that capability, and make sure that we didn't just leave everything with scorched earth where we just rip everything down and make it all go away. So we were able to reutilize big parts of the Space Center, and now we're reaping those rewards as a result of that.
Lily, do you have anything else you wanted to add?
I mean, I'll add it as a last question. Are you excited about about the future with Mars and the colonization of Mars? Any hot take on that?
Well, I think NASA's current plan, and I think that probably the right thing to do is to go to the moon first. I think we need to where you're only a couple of days away instead of a trip that might take 6 months. I mean, plus NASA's current plan includes the Gateway, which is not a space station where it's actually circling the Earth, but a outpost that's somewhere between the moon and the Earth. So we would practice all of the techniques that we need to live on the surface. Do that on the moon first. Make sure we've got all our technologies developed. Make sure we know how they operate. Because the Mars is a lot longer stretch. I mean, 6 months just to get there. Once you're there, you're going to want to spend some time there. Another 6 months to get back. It is a year-plus mission that you have to be ready for. So it is exciting. A lot of the work we do in Swamp Works is directly in support of that. Trying to get ready to live on the moon and Mars. So, and that whole organization is, I'm part of that group.
Yeah, it's crazy
So,
that you're working on these things. It's like a couple decades ago, people would have thought, oh, we're gonna colonize Mars, but it's starting to become a reality. It's crazy.
It's a tough thing to do.
Yeah.
are there more questions in the chat, Riton?
Oh, okay. So it's other people have asked, what is the most important impact the projects you've worked on have had?
Well, there's a lot of impacts that right now on the current work I'm doing. Some of that is more on the lines of research. So you don't really know how it's all going to turn out, and what technologies that we develop and how they're going to be used. I mean, this as I'm talking about my solar radio burst detector project. That's an important part of understanding space weather. If we understand space weather, then it's those solar bursts that can interrupt satellite communication and tear down our electric grid. While we can't necessarily do anything to prevent the sun from bursting, what we can do is, if we can detect it early enough, we can be prepared. First of all, if you understand the physics behind it, you can build your systems to withstand much of the bursts that occur, but you're not going to be able to stop everything. So what you can do is if you're aware that it's coming, you can do things like turn off your satellites. You can turn down the electric grid for the astronauts that are in space. They can go in a shielded room for a short period of time so that they don't get exposed to significant amounts of radiation. And the only way to get to that point is to be able to measure the sun first. First, you got to measure it. Then you understand it. Then you can prepare for it. There's a lot of work that I'm currently doing that I don't know how it's all going to turn out. But I do know the work that I did as part of the shuttle program. Every time the shuttle landed successfully, I knew I was a big part of that. That was also just as important.
part of the fun.
Yep.
So I think we're kind of closing off here,
Okay.
unless for Thomas more questions. We do want to thank you again for coming, and then I guess just as a last minute kind of thing, the audience is primarily high schoolers and probably a little middle schoolers. Any specific pieces of advice for similar-minded kids working in this STEM area?
Yeah, I'd say, as I mentioned before, it's those difficult courses that tend to be motivating. When there's a significant challenge, that can drive a lot of individuals. But even if you are soft or unsure in certain areas, like don't give up. I wasn't necessarily the strongest in math in high school. I was okay, average, doing all right. But by now I've probably taken more math courses that I can count. And so you don't give up. You take it again. If you find an area that you're struggling with, instead of avoiding it, you should actually go and take it on and take more. And maybe you won't do great the first time around, but I guarantee you, the second and third time you learn something, you really start to pick it up. There's a lot of things that you're here for the first time and just right over your head, and that's okay. But being exposed to it over and over, you really start to understand it. So do not give up. Repeat if you need to. Another thing I'd pass to the middle and high school kids is don't ignore the reading part. I can't tell you how many times that I've got 5 children of my own. So far, 3 of them have graduated college. And one is in college and one's in high school. And I would say, spend the time reading the material. That is an important part of it. I know a lot of folks tend to just focus on the homework, focus on the exams, and then forget to go back and actually read the textbook. They'll skim the textbook and just kind of flip through it. And, it's worth reading, and don't read just one source. Go get other sources. Whether they're electronic or books. Either way, get a bunch of sources, compare what they have to say. And that's one of the good ways to learn.
Yeah, different viewpoints.
Yep, exactly.
I think even NASA has informational pages about things too. So whenever I look up physics problems, they always have a little excerpt on it relating to the aeronautical side of it. So thank you so much again, Tom. Any last words? Thank you?
Thank you so much. It was an honor to talk to you today.
I'm glad. Thank you for inviting me, and I hope this is valuable for folks out there.
Well, that's all I got. So.
All right. All right. I guess.
Decades. We'll see the research. Okay.
All right. I guess we'll go ahead and sign off then.
You're welcome to go. Yeah. Thank you again.
All right. Thanks a lot. Bye-bye.